Question number 8. The cone is made from the following sector. Find correct to three significant figures. A, the slant height. S. So first thing I noticed, the slant height is the hypotenuse of this right triangle through the center of the cone. So the right triangle that we have here has a height of 10, and the base is the radius of the cone, which is 6. So S squared is equal to 10 squared plus 6 squared using Pythagoras theorem. And I figured out that the slant height must be equal to the square root of 136, which is approximately 11.66 centimeters. So if I do that to three significant digits, 11.7 centimeters. Part B. Well, want to find R. Well, if you look at the two pictures, R is the same as the slant height of my cone. So it's also 11.7. And then if I look at my circumference, my arc length, that's equal to the circumference of the cone's base. And I know that I can find circumference by doing 2 pi r, where r is 6. That's the radius of the cone. So my arc length is 12 pi, which is approximately 37.7 centimeters. So 37.7 centimeters to three significant digits. Notice I just wrote 4 on all these for some reason. I misread the instructions. Alright, so D. The sector area angle theta. Well, I know the arc length already. And so I know the radius, which I found in part A. So all I have to do is solve this equation for theta by dividing by 11.6619 and then rounding the three significant digits, which is approximately 3.23 radians. So theta is 3.23 radians. All right, question number 9. I'm going to find this wall is designed like the picture A, and we want to find theta. Well, I know two sides of this right triangle. I know the base is 15 and the height is 5. So I ask myself, what trig function involves opposite and adjacent side, which is the tangent. So tangent is equal to 5 over 15. So if I need to solve for the angle measurement, I do the inverse tangent function. So the arctangent of 1 over 3 is equal to alpha. So alpha is approximately 18.43 degrees to 4 significant digits. Then B asks us to find theta. Well, I notice if I have these two angles have to be the same, so I got 2 times alpha plus theta, and that's going to equal a straight line or 180 degrees. So substitute in what I know and then solve for theta. I get theta is approximately 143.1 degrees. Find the area of the wall. So if I want to find the area of the wall, I'm going to find the area of the triangle and times it by 2. So 2 times the area of the triangle plus the area of the sector. So visually, think about this. I'm finding this triangle plus the area of this entire sector here. So area is going to be equal to 2 times, well, the formula for area of a triangle is 1/2 base, which is 15, times height, which is 5, plus, now notice my theta is in degrees, so I'm going to use the degree formula for the area of a sector. So that's going to be, I need to find my radius first with this r, or length of side CB. Well, that's going to use Pythagoras theorem to find the missing side. And I find that r is equal to 250, the square root of 250, sorry. So, area of a sector. Well, theta, 143.1, divided by 360, times by pi, times by r squared. So the square and square root cancel out, and that just becomes 250 times pi. Simplifying this down, I get 75 plus. And A is my area of the wall is approximately 387 square meters. This one didn't specify what to round to. Number 10. The key is that AT is tangent to the circle, so that tells me I have a right triangle. If I didn't know it was tangent, I wouldn't know I had a right triangle. So this is going to be key. Now, since I have a right triangle, let's see what we know. We know the radius is 5, and I know this length OA is 13. So I know two sides of a right triangle. So I can find theta by using the trig function that involves the adjacent side and the hypotenuse, which is cosine. So cosine of theta is equal to 13 over 5. So to find theta, I'm going to do the inverse of the cosine function. So arc cosine of 3 over 15 is equal to theta. So theta is approximately 67.38 degrees. Now I know theta, I can find some other information. So let's use Pythagoras' theorem to find the missing side of this right triangle, or side TA, which I'll call x. And I get x is equal to 12. So segment TA is 12 centimeters long. And then let's find, we're asked to find the perimeter. Well, the perimeter is going to be the length of TA plus the length of VA plus the length of the arc TV. So TA I found using Pythagoras' theorem, which is 12. VA I can easily find by taking the full length of this line segment and subtracting the radius of 5. So it gives me an 8. So line segment TA is 12, AV is 8. Now I got to figure out the arc. Well, I'm going to use the arc formula, but I'm going to use in degrees. So I have my arc, my theta divided by 180 times pi times 5, which is the radius of that central circle. Adding that all together, I get my perimeter is 5.88 centimeters. Okay, let's look at the Earth one and talking about nautical miles. Given that the radius of the Earth is 6,370 kilometers, show that 1 nautical mile is approximately equal to 1.853 kilometers. All right, so what's my angle measurement? My angle measurement is 1 over 60 degrees. So I'm going to change that into radians. So that's going to be pi over 10,800. And then my arc length is equal to theta times r, so pi over 10,800 times my radius, which they told me is 6,370. Multiplying this together and then simplifying. My arc length is 1.853 kilometers. Yes, that's exactly what I needed to figure out, so I've proven it. B, calculate how long it would take a plane to fly 480 knots. So I have to know that speed is equal to distance divided by time, or if I rewrite this and solve for time, because that's what I want to know, time is equal to distance divided by speed. So I just figured out that my distance I need to travel is 2,130 kilometers. That was given to us. And the speed is 480 knots. Well, knots unit of measurement was also given the problem, which is nautical miles per hour. Well, we just figured out that 1 nautical mile on the Earth is equal to 1.853 kilometers. So I'm going to replace this to 480 times, convert nautical miles to kilometers. So I have kilometers on top and kilometers on bottom. Then my kilometers units will cancel each other out. My time is left in hours. Do my division, I get 2.395 hours. Now, you can also convert this to hours and minutes, which makes more sense when we're talking about flying a plane. So I just take the decimal equivalent and I times it by 60 and round to the nearest minute. So this is 2 hours and 24 minutes. Question 12. A sheep is tethered to a pole that is 6 meters from a long fence, and the length of the rope is 9 meters long. Find the area the sheep can feed from. So let me get this kind of drawn out. So if he went straight to the wall here with his 9 meters, he'd go this distance, and then he could go out from the wall 9 meters all the way around. So it's going to form a nice little circle. Pardon my drawing. This should be a nice pretty circle. Alright, so the area the sheep can travel is all of this in between. So let's see. Let's label a few things. I'm going to call these angles inside the triangle theta and the angle outside beta. So cosine of theta is equal to adjacent over hypotenuse. So the angle whose cosine is 2/3 is approximately 48.19 degrees. So I figured out theta is 48.19 degrees. Now to find beta, I know if I add 2 thetas plus the beta, that's going to give you 360 degrees. So 2 times 48.19 plus beta equals 360. Solve for beta. Beta is approximately 263.62 degrees. I also know that the distance that from this fence from T, let's label a few things. No, let's not use X. Let's call this A, M, and B. So the line segment MB is equal to 9 squared minus 6 squared using Pythagoras theorem. Well, that should be MB squared. Let's fix that. Is MB is equal to the square root of 45. I've added some shading to help us figure out the area of the feeding area, which is the area of that big pink triangle plus the area of the yellow arc sector. So area of triangle is 1/2 base times height. But I have 2 of these triangles, so I'm going to do 2 times 1/2 base, which is square root of 45 times height, which is 6, plus area of the sector. Well, the area of the sector is 1/2 theta, but let's convert that into radians by multiplying by pi over 180 times by radius, which is 9 squared. And then just simplify, work that all the way out, and you end up with 227 square meters. All right, let's do one more example. So I have this pie that I've cut into 12 pieces, and the pie was baked on a 10-inch diameter. So looking at one piece here, and if I have 10-inch diameter, that means the radius is going to be 5 inches. Now, if each of these have equal pieces, all of these angles around these things, let's call them all theta. Well, if I have 12 pieces, I know that 2 pi is equal to 360 degrees, or all the way around the circle. So that means that a theta, I divide by 12, is equal to pi over 6. So area is 1/2 theta times radius squared. Just punching this into my calculator and simplifying down. I'm first going to write all the decimals because I might use this calculation later on. And then I'll simplify the final answer. So that means the area of one sector of pi is approximately 6.54 square inches. Now I'm going to do a circle through the middle, a circle that's going to make these 2 pieces of the pie equal. So I need to make 2 equal pies, and I need to figure out how far to cut this from the center of the circle to make 2 equal pieces of pie. So first, the area of the new piece of pie needs to be half the area of the original, so I can make double as many equal pieces. So that's area is 3.27 square inches. Now, let's say the distance or radius of this new smaller piece is going to be x, while the area is going to equal to 1/2 theta, which is still the same, times x squared, my new radius. And then I already know that area is 3.227. I'm going to do a few more decimal places and round at the end. And then I just solve for x. So I end up that x is approximately 3.54 inches from the center. So let's see, how would I write that as a sentence? You should cut about 3.5 inches from the center of the circle to form the 24 equal pie pieces.